Hello everyone, and a special welcome to all the exam aspirants out there. The World Meteorological Organization just dropped its latest report on greenhouse gases, and frankly, the numbers are pretty staggering. We're going to break down everything you need to know from this report, focusing on the key facts and concepts that are absolutely crucial for your exams.
Let's just jump right to the headline number 3. 3.5 parts per million. That's how much the concentration of carbon dioxide in our atmosphere shot up in a single year, between 2023 and 2024. Now, what's a ppm? Well, think of it like one drop of ink in a huge barrel of water. It sounds tiny, but in the atmosphere, it's a massive deal. This is the single largest one-year jump we've ever seen since we started keeping detailed records back in 1957. It's a sign that things are accelerating and fast.
Okay, so here's our game plan for this explainer. We'll start with that record search, then do a deep dive into CO2 itself. After that, we'll tackle a really critical concept, why our planet's natural carbon sinks are starting to fail. Then we'll cover the other big gases, put it all in a global context, and finish up with a super condensed list of key takeaways just for you.
Right, so all the information we're discussing today comes straight from the WMO's 21st Greenhouse Gas Bulletin. This isn't just some random report, it's the authoritative source, released on October 15th, 2025. Let's get into the findings.
Now let's focus on the main culprit, the primary driver of all this, carbon dioxide, or CO2. We need to really understand why this acceleration we're seeing is setting off so many alarm bells.
Look at this timeline. It tells a really powerful story. It's not just that CO2 is going up, it's that the speed at which it's going up is increasing. Back in the 60s, the atmosphere was adding less than 1 ppm each year. Jump to the last decade, and that rate had already tripled to 2.4 ppm a year. And now, a single year saw a jump of 3.5 ppm. That pattern of acceleration is a fundamental concept you need to grasp.
And that accelerating growth rate has led to this. Look at the total amount. In 2004, the global average was about 377 parts per million. Just 20 years later, which is nothing in planetary terms, it shot up to nearly 424 ppm. That is a colossal amount of extra heat-trapping gas added to our atmosphere in a very, very short time.
So, the big question is, why such a massive spike right now? Sure, emissions are still a huge problem, but the report points to something even more worrying. It seems the Earth's own natural defense systems, its buffers, are getting weaker, and that's creating a dangerous, vicious cycle.
First, let's lock down a key term you'll definitely see in your exams: carbon sink. What is it? Simple. It's any natural system that acts like a sponge for carbon dioxide. Think of massive forests or the world's oceans. These sinks are amazing. Historically, they've been soaking up about half of all the CO2 we've been pumping out, which has really put the brakes on climate change. So if they're so great, what's the problem? Well, they're becoming less effective. For one, as oceans get warmer, they just can't hold as much dissolved CO2. It's a bit like a warm soda going flat. It releases its gas. On land, the strong El Niño in 2024 caused widespread droughts, meaning forests were too stressed to absorb much CO2. And that dryness led to huge wildfires, which is a double whammy. They stop absorbing carbon and they release all the carbon they've stored. This creates what scientists call a climate feedback loop, a vicious cycle. The warmer it gets, the weaker the sinks get, which causes it to get even warmer. It's a critical concept.
Okay, we spent a lot of time on CO2, but it's not working alone. Let's turn our attention to the other major long-lived greenhouse gases because they also hit new record highs.
Check out these numbers. In 2024, methane levels reached 1942 parts per billion. That's a B for billion. That's a mind-blowing 166% higher than before the Industrial Revolution. Nitrous oxide hit 338 parts per billion, which is a 25% increase. Now, don't let the smaller ppb numbers fool you. On a molecule-for-molecule basis, these gases are way more powerful at trapping heat than CO2. They really punch above their weight.
A classic exam question is, where does all this methane come from? Well, it's a mix. About 40% is from natural sources, like wetlands. But the majority, about 60%, is from human activities, what we call anthropogenic sources. We're talking about things like agriculture, especially from livestock and rice farming, plus fossil fuel operations and even our landfills.
All right, time for a quick exam hack. It can be tough to remember the top 3 greenhouse gases in order of their impact. So here's a simple mnemonic for you. Just remember this phrase: climate must not be ignored. The first letter of each word gives you CO2,
methane, and nitrous oxide. A super handy trick for when you're under pressure.
Okay, let's zoom out. For your current affairs prep, it's really important to know who the key players are in this space and what major events are on the horizon.
So there are 3 names you absolutely have to know. First, the WMO, the UN agency that puts out this bulletin. Second, the Global Atmosphere Watch, or GAW. That's the actual WMO program that coordinates all the data collection from around the world. And third, COP30. That's the next big UN climate change conference happening in Brazil. You can bet this data will be a huge topic of discussion there.
We have covered a ton of information. So, to make your revision easier, we've boiled it all down to the absolute essentials. If you're gonna remember just one slide from this whole explainer, make it this next one.
Let's do a lightning round recap. The record CO2 increase, 3.5 ppm. The total CO2 level now, 423.9 ppm. What's causing it? Emissions, sure, but also wildfires and failing carbon sinks, made worse by El Niño. Methane is at 1942 ppb, a 166% increase. Nitrous oxide is at 338 ppb, a 25% increase. The organization behind the report is the WMO, and the big upcoming event is COP30. That's your cheat sheet.
And remember, these aren't just abstract numbers. They have very real consequences. As the WMO's Deputy Secretary General, Co Barrett, put it, the heat trapped by CO2 and other greenhouse gases is turbocharging our climate and leading to more extreme weather. That really connects the data directly to the heat waves, floods, and storms we're seeing around the world.
So I'll leave you with a final thought, a question that's perfect for your analytical essays. We all know cutting emissions is priority number 1. But what does this report tell us? It tells us the planet's own ability to help us is getting weaker. So the big question for policymakers is this: as these natural buffers fail, how do we need to adapt our strategies? It's about more than just cutting emissions now, it's a whole new level of challenge.